Hi, everybody. I hope you're having a great day. Today is August 27th, and in Algebra 3 today, we talked about factoring. If you are sick or quarantining or maybe just weren't in class, I want to try to give you a little heads up about what we're doing. In the last few days, we have been doing what's called expanding or distributing or maybe even multiplying things out, and factoring is really like the antithesis. It's the opposite of those things. And so really, when we think about it, we can go, well, when you're factoring, you get to the factored form, and then when you multiply or distribute things out, you then are kind of expanded, and then you can take that and you can go to factor. Let me give you a better example. If I have something that says, say, 2x times y minus z, okay? The question is that the factored form or is that the expanded form? Well, you think about, when I think about expanding, I think, well, I need to multiply or I need to distribute. Well, clearly that's what this problem or this expression really wants, is it wants to be expanded, multiplied, it wants to be distributed. So this is the factored form. And this is what we've been doing. We've been given problems like this and we need to distribute them out. And so you take the 2x and times it by y and you get 2xy. You take the 2x and times it by z and you get 2xz. Okay, and this right here, it would be called then the expanded form. Now the funny thing is you might look at this second one and go, oh, hey, check it out. This has got a 2x and this has got a 2x. I could factor that off to the front and I get 2x times y minus z. And what did you do? Well, you just got back to where you were. Okay, so at some point you got to get off this revolving door and be either inside or outside. So all of the problems that we had from the last section is they gave us this form. They gave us the factored form, and our job was to then distribute or to multiply and basically give the expanded form, which was right here. Now, in what we're going to talk about is we're going to be given the expanded form, something that has been distributed or multiplied out, and we've got to factor it. Okay, so let's do an example. Here's the most basic. This is, while this problem might look a little crazy, this is kind of really a basic Algebra 1 factoring problem. And so what I'm going to do is I'm going to break it down as if I was teaching Algebra 1 right now. Okay, I'm going to look at and see what are the components of each one of these terms. In this first one, I would look and say, well, it's really 3 times x times y times z times z times z. And the second one would be 3 times 3, that's where you get that 9, times x times y times y times y times z times z. Okay, and so now what I can do is I go, what do they have in common? All right, well, they each have at least one 3. This one's got a pair of x's, but the other one only has one x. This one has a single y, and this one has a bunch of y's. And this one has 3 z's, but the other one has 2 z's. And so we can go, well, we can take out at least 2. Because what you can factor out is you can always factor out the things that are shared. And these things that I have highlighted are the only things that are shared among these two terms. So those are the things I can factor out. So the thing that factors out is going to be 3x, y, z squared. Those are all the things that the two terms have in common. And when you factor that out to the front, you can basically kind of cancel those out from right here. And you're going to go, okay, so what do I have left? Well, in this first term, all I have left is xz. And in the second term, I have a 3, and I have a couple y's, so I got 3y squared. Okay? And so this right here was the expanded form. Okay? And this right here is the factored form. And so that's what we did. We factored it, and we got to this right here. And that's what we're doing right now. Okay? This was a very basic form of factoring. All right, let's look at another example. This also is in Algebra 1, a little bit into Algebra 2 kind of problem. You might not remember this, but if you're going to factor a trinomial, it's got 3 parts, so it's called a trinomial. If you're going to factor a trinomial, the number one mistake that Algebra 1 students who look at this and think they've got it conquered, they kind of take this other mindset where they're looking for things in common among the two terms. And the problem is, with this trinomial, there is nothing that all 3 terms have in common. Okay, they don't have something in common. And so what I look at this is some people will then say, well, but this first term has an x and the second term has an x, so I'm going to factor that x out and they're going to be left with this. And if they do that, what a mess. That doesn't help you at all. Okay, now I just have this thing that's partly factored, and that doesn't really help. And so don't ever do that. Okay, that's not what we want to do. When we're factoring trinomials, there was this little trick. We looked for 2 numbers that multiply together to give me that, but when I'm add them, I get this. So what two numbers multiply together to give me 10, but when I add them, I get negative 7? And the answers are negative 2 and negative 5. And so you write x minus 2 times x minus 5. There's my negative 2 and my negative 5. Now, if you go, wait a minute, how in the world does that work? Well, just multiply it back out. You would FOIL this. X times x would give me x squared. X times negative 5 gives me negative 5x. Negative 2 times x gives me negative 2x. And negative 2 times negative 5 is positive 10. Combine those middle two terms, and sure enough, this is what I get. Now I'm back to the beginning, because I didn't want to do everything that's in green. I was just trying to factor. And this is the factored answer right there. I just went back and did these things to prove that that's where we came from. Okay, so what I'd like you to do is, if you're watching this, I'd love for you just to kind of get, remembering these things, is try these three. They're all really basic. So pause the video right here, and then we can pick up and I can work through these in just a minute or two. But I would love for you to try these. Okay, go for it. Just pause it. Okay, so hopefully you got all these done. I'm going to just blast through them real quick. We're looking for two numbers that multiply together to give me 15, but when I add them, I get 8. And so I know that that's going to be positive 3 and positive 5. Okay, this next one, I'm looking for two numbers that multiply together to give me positive 20, but when I add them, I get negative 9. And that would be negative 5 and negative 4. And so there's my negative 5 and negative 4. And this one, it might be a little bit tricky. I'm looking for two numbers that multiply together to give me negative 48, but when I add them, I get negative 2. Now, the fact that this is negative means that one of the numbers has to be positive and one of the numbers is going to be negative. And so I go, well, 6 and 8 multiply together, give me this. And if the 8 was negative and the 6 was positive, then it would give me this when I add them. Okay, so it's going to be x minus 8 times x plus 6. There's the two numbers, the negative 8 and the positive 6. Okay, so hopefully those are the same answers that you got. And these things were really easy. I remember when most students learn these, when I've taught these in the past, as most students have gotten to this point, I know that this is where they usually go, hey, this stuff is easy. And so anyway, what I want to do though, is some people think, man, I've really kind of, it's easy, but it doesn't seem really mathematical. It doesn't seem really systematic. It's just like this quick little jump. So what I want to do is I want to go, okay, let's talk about all the steps that are there, because we skipped a bunch of steps. But we skip the steps because they're so easy. But if we change this problem and make it just a little bit more difficult, we've got to have those steps. So let's talk about what we're really doing. In this one, if I'm looking for two numbers that multiply together that give me negative 24, but when I add them, I get negative 5, let's see, that would be negative 8 and positive 3. Now, so we know that I'm just going to get this as x minus 8 and this x plus 3, but I want to go, how do we actually get there? And so what we do is we go, okay, if these are my two numbers, then I need to split this negative 5 into those two numbers and rewrite it and say x squared minus 8x plus 3x minus 24. And you might ask, well, wait a minute, how can I split this negative 5 into these two values? Well, because when you add them together, negative 8x plus 3x, that's going to give me negative 5x. So I can do that, all right? And so now what we do is we do something called factor by grouping, okay? And so what we're going to do is we're going to group these first two values and we're going to group these second two values and we're going to factor them independent of each other. So we go, what do those first two values have? Well, they have an x in common. And that if I factor that x out, it would leave me with x minus 8. And what do these second set of numbers have in common? Well, they got a 3. So if I factor that 3 out, I'd be left with x minus 8. And isn't that amazing that I have an x minus 8 here and an x minus 8 here? Now, this is the only tough part, the one thing that people struggle with. So I'm going to ask you to pause doing this problem for a second, and let's pretend that this didn't say x minus 8, but it was a big fat A, okay? And so this actually said x times A plus 3 times A. I want you to imagine it said that for a second. And I told you to factor that. X times A plus 3 times A. Well, that's easy. You go, well, what do they have in common? They have A in common. So it'd just be A times X plus 3. Done. Well, we're going to do the exact same math on this other one. It doesn't have just an a. It's got more than that, okay? So instead of having an a, it has an x minus 8. But we're going to do the same thing. We're going to take that x minus 8 and factor it out to the front, which would leave us with x plus 3. Remember, we said if we factored that, if this was x times a plus 3 times a, we factor that a out to the front, which would leave us with a times x plus 3, and that's what we did, is we factored out that a out to the front, and it left us with x minus 8 times x plus 3, which is exactly what we knew we were supposed to get. So this is the actual way of doing it. Now, most people say, well, I could really just kind of skip to the end. And that's true. And that's exactly how we did these. We skipped right to the end. But if I make this problem just a little bit more difficult, we can't skip to the end without doing these steps. So what I want you to do is I want you to practice these steps and try to solve these two, okay? I'll scoot back up. I'm going to scoot these up here so you can see the steps that we did, okay? And I want you to try to solve this A and B problems using these steps. So go ahead and pause the video here for just a minute or two, and then I'll work them out. Okay, all right, let's take a look at this. If I'm going to use these steps, I'm going to say what two numbers multiply together to give me 24, but when I add them, I get 10. The numbers are 6 and 4. So I'm going to say x squared plus 6x plus 4x plus 24. What did I do? I split that 10x into two parts. Then I go, okay, let's factor the first two. What do they have in common? An x. So I take out an x, and I'm left with x plus 6. What do these next two have in common? A 4. So I take out a 4, and I'm left with x plus 6. And again, look at that. I have that thing in common, that x plus 6. So I factor that out to the front, and I get x plus 6 times what's left? X plus 4. Here's my x. Here's my plus 4. That's pretty easy. Now, what's funny is some of you might be sitting at home right now, and you did this problem differently. You might say, wait a minute. I did it differently, and I got a slightly different answer. And so I want to take a look at that, because maybe what you did is instead of doing breaking this up into 6x and 4x, maybe you broke it up into 4x and 6x, which is really the same thing. It's just in a different order. And so this problem will actually solve the same way. Again, what can you take out of these first two terms? An x, which leaves me with x plus 4. I can take a 6 out of these two terms, which leaves me with x plus 4. And then I factor that out to the front. I'm left with x plus 4 times x plus 6. And what did I have a second ago? Well, I had x plus 6 times x plus 4. Multiplication is commutative. You can multiply in any order, so those two are really the same answer, okay? So it doesn't matter what order you break up that single middle value. It doesn't matter how you break those two up. It matters how you break them up. It doesn't matter what order you put them in. Okay, let's look at this next one. So you go, what two numbers multiply together give me negative 40, but when I add them, I get negative 6. The answers are negative 10 and positive 4. So I say x squared minus 10x plus 4x minus 40, okay? All right, and with this one, here, you know what? I'm going to switch that around just because we'll run into something a little bit different if we go x plus 4x minus 10x minus 40. I'm going to show you in a second. Okay, so what can we get out of these first two? Well, we can take an x out, which leaves me with x plus 4. Now, here's what happens. If this middle term, if the middle operator symbol, rather, ever is negative, that whatever it is, whether it's positive or negative, you're going to factor that. Notice in this one, the middle operating term was positive. I factored out a positive 6. If it's negative, you're going to factor out something negative, okay? So in this case, what do the two things have in common? A 10, which that means I'm going to factor out a negative 10, leaving with x. And when I take a negative 10 out of negative 40, I get a plus 4. And see, now these two match. If I didn't take out a negative 10, then these two wouldn't match. You'd have x minus 4 in the second part. So you go, okay, now factor that out. You go x plus 4 times x minus 10. Simple, okay? Now I know most of you could just go straight from here to here, but now what we're going to do is we're going to see a problem where you couldn't have done that. See, what happens is if you've got a coefficient on that leading term, then all of a sudden this doesn't work. You can't say, hey, what are two numbers that multiply together to give me negative 12, but when I add them, I get negative 5. You go, well, 3 and 4, no, 2 and 6, no, 1 and 12, no, nothing. And it's because it has this leading coefficient. So whenever you have a coefficient on that front term, you always have to multiply that times the back term. okay? You always multiply this front number times the back number, which in this case, 3 times negative 12 gives me negative 36. Now, this is the value I'm trying to break up into two values that add up to give me negative 5. Well, that would be negative 9 and positive 4. Okay, negative 9 plus 4 would give me that negative 5. So what I do is I break this up and say 3x squared minus 9x plus 4x minus 12. And I can factor what can come out of both of these. The answer is a 3x, which would leave me with x minus 3. What can come out of both of these? The answer is a plus 4, which leaves me with x minus 3. So then I factor out that x minus 3, and that leaves me with a 3x plus 4. There we go. And that's how we factor it. But see, I couldn't do this by just the easy one-step method. I have to know this other method, this factor by grouping. Okay, so what I want you to do is hopefully if you were able to do those, hopefully you could do this one other all by yourself. I'd like you to give it a try. Remember, you multiply that first term times that last term to give you that number that you need. So go ahead, pause the video right here, and in 1 minute, I'll do this problem. Okay, let's give it a try. Well, 2 times negative 15 is negative 30. So that's the number I'm factoring. I go, well, what two numbers multiplied together give me negative 30, but when I add them, I get negative 7? Well, that would be negative 10 and positive 3. So I say 2x squared minus 10x plus 3 minus, or 3x, I'm sorry, minus 15. Now, you might have also written it 2x squared plus 3x minus 10x minus 15, and it can be done either way. What can I factor out of these first two terms? In this case, I can factor out a 2x, which would leave me with x minus 5. What can I factor out of both of these? I can factor out a 3, which would leave me with x minus 5. So I factor out the x minus 5 to the front, and that leaves me with a 2x plus 3. Let's look at this other one. What can I take out of both of these terms? The answer is just an x, and that would leave me with 2x plus 3. And what can I take out of both of these terms? Remembering that whatever that middle operator symbol is, I always take that out. So I'm going to take out a negative something, negative 5. If I take out a negative 5 out of the negative 10x, I'd be left with positive 2x. And if I take a negative 5 out of the negative 15, I'd be left with a positive 3. And look at that. I've got 2x plus 3 and 2x plus 3. So I factor that out to the front and say 2x plus 3 times x minus 5. And look at, it's the exact same thing as I have here, just in a different order. But multiplication is commutative, so it doesn't matter. All right. I hope these made sense. If they didn't, please watch the video again. Email me if you got any questions. Have a great day.